This video is a vocabulary sheet that we're using to help us through our lesson 3 notes. Previously, we have completed what we call geometric proofs, and geometric proofs are when you complete a problem and you justify each step. The problem could be any type of geometric problem. These require you to know all your theorems, postulates, examples, definitions, everything that you learn in geometry are required throughout proofs. However, this year we are just doing basic property of equality proofs or property of equality justification examples. So the vocab on this sheet is going to be all you need to know, plus a few other basic ones throughout the note sheet of topics we've already learned. But for the most part, this vocab sheet has everything on it. Again, we are only going over properties of equality this year for our so-called proofs. I'm going to briefly read through each one of these, but you are going to want to save this sheet. You're going to want to keep it out in front of you while you are going through your notes for today. This is going to be so helpful because these are your answers for every step. Okay, the first property of equality is the addition property of equality. The addition property of equality tells you or identifies that you can add the same number to both sides. So if the example is A is equal to B, then you could add C to both sides and you're keeping the equation equal. If I gave you an example of when you would use the addition property of equality, it would be when you're solving a basic algebraic expression, such as x minus 3 is equal to 7. The addition property of equality is what allows you to add 3 to both sides, keeping the equation equal, but solving for x. So this would give you a solution of x equals 10. This step right here, by adding 3 on both sides, is what we call the addition property of equality. Next is the subtraction property of equality, and as you can imagine, it's very similar. The subtraction property of equality says that if A equals B, you can subtract the same thing from both sides, and this allows you to keep your answer or keep your equation equal, but also solve for maybe a missing variable. My example could be y plus 5 equals 11. To solve for y, you would subtract 5 from both sides, giving you the solution of y equals 6. This is called the subtraction property of equality. Subtracting the same number on both sides allows you to get the answer. So following along with the different operations, we now have the multiplication property of equality. This property allows you to add the same term to both sides. If A is equal to B, then A times C is equal to B times C. When we are solving, an example of the multiplication property of equality could be if you have something such as 1/4 times Z is equal to 6. If you multiply both sides by 4, that's going to eliminate your fraction on the left side, giving you the solution of Z equals 24. We multiplied both sides by 4, we get an answer, multiplication property of equality. The division property of equality allows you to divide something by both sides, divide something on both sides. An example when solving could be 8x equals 16. In order to solve for x, you would have to divide both sides by 8. X is equal to 2. So I'm sure you're seeing the pattern throughout these first 4. These first 4 are operations, and I'm just going to make a note of that. You probably should as well. So operations include addition, subtraction, multiplication, division. These next 3 are just properties that are going to allow us to solve. We're not going to use these 3 too much this year, Previous years, we have spent a lot of time with them. This year, we're just asking that you know what they are. So the first one is the reflexive property of equality. And the reflexive property of equality states that if you have something, it's equal to itself. If I gave you an example, you could say segment AB is equal to segment AB. Next is the symmetric property of equality. The symmetric property of equality allows you to switch the order you are writing your answer in. So for example, if you were solving, you could say x equals 6, or you could say 6 equals x. It doesn't matter which way you write it. This property, called the symmetric property, allows you to write it either way. And the last one of these three is called the transitive property. Transitive is kind of like process of elimination. This is saying that if A equals B and B equals C, then A equals C. If both A and C are equal to B, then A and C must be equal to each other. So if I gave you an example where we could see this, I could say A is equal to 6. I could say 6 is equal to x. So therefore, if both a and x are equal to 6, we know that a is equal to x. We eliminate that middle term. We know that those last terms, a and x, are equal. Next is the substitution property. We're going to use the substitution property a lot, especially in today's notes, because we are going to be solving for algebra or algebraic problems. So we're going to have to substitute our values into our equations. You all should know what the substitution property is. The substitution property states that if A is equal to B, then A can be substituted for B in any equation or expression. For example, if you know that x is equal to 6, and you have a function that says 2x is equal to 12, you can substitute 6 in for x. That's called the substitution property. It's when you substitute your value into the equation. And the last property is called the distributive property, also a property that you have previously learned about. The distributive property allows you to distribute a term outside of the parentheses to both terms inside of the parentheses. My example here says A times, in parentheses, B plus C. This is equal to A times B plus A times C. Another example could be 4 multiplied by x plus 2. If we use the distributive property here, we distribute 4 times x, which gives us 4x, and 4 times 2, which is 8. This is your solution using the distributive property. And the absolute last thing we're going over for your vocab today is simplifying or combining like terms. So when we're working on justifying our steps, if there's a step in your algebra process, I'll leave it like that, that requires you to just simplify or add like terms together, then your justification is going to be combine like terms or simplify, whichever you choose to use. And you'll see what I mean by that when we go over the actual note sheet. But for now, everyone should keep this vocab sheet out in front of you. It's going to be extremely helpful for today's notes. Also, it will be helpful for the rest of the year, which is why I separated it from today's notes. That way you can easily just keep one paper out instead of a whole note packet. And you can also access this video at any time.